Why don't we go ahead and get started? Okay, again, today's topic is an introduction to user-defined function blocks for our tag-based advanced ladder logic. Okay, let's take a look at the agenda today. Of course, we'll cover what are user-defined function blocks. Lots of demonstration time today. We'll show you how to create the user-defined function blocks, how to use them throughout your program. We're going to show you debugging, because that's obviously important. You don't want to be replicating code that isn't well proven and working without a flaw. And also, we're going to show an example of nesting user-defined function blocks as well. And we'll cover some of the features of the Cscape implementation for UDFBs. And as always, we'll have time at the end for questions and answers. Okay, let's start by answering the question, what are user-defined function blocks? Well, as the name implies, these are function blocks that are created by users. Of course, Cscape comes with a whole number of standard function blocks used in ladder logic, shift registers and move blocks, etc., etc. But user-defined function blocks are function blocks created by users. It's a very efficient way of creating reusable code, and it's supported in two different Cscape logic styles. Now keep in mind, there's only one version of Cscape, and if you're configuring screen graphics or configuring I/O, setting up communications and networking, that's the same regardless. However, we do give you some choices when it comes to programming your logic. There's the traditional advanced ladder, which is register-based. So with that option, you need to map your variables to registers. And that option has been around the longest and does not support user-defined function blocks. We have advanced ladder with tags, which starting with Cscape 9.9 Service Pack 3 is supporting user-defined function blocks. And then we have our IEC 61131 language set, which has been around for some time and has supported user-defined function blocks for a majority of that time as well. Now, the logic within the function block is comprised of standard instructions, whether those are Boolean instructions or, again, other function blocks, or even other user-defined function blocks can be embedded in a UDFB. One of the key features of UDFBs is that you can use multiple instances of them scattered throughout your code. They're instantiated, as they say. One question we get asked a lot is, how does a UDFB compare to a subroutine? Well, subroutines are called using the call instruction. And you can have multiple call instructions throughout your code, but no matter how many times you call the subroutine, you're calling the same section of code with the same variables. User-defined function blocks, however, can be placed directly in the main logic blocks scattered throughout your program. User-defined function blocks have multiple instances. Subroutines, again, only have a single instance with a single set of variables, no matter how many times you call it. Whereas UDFBs have a unique set of variables for each instance. That's probably the biggest difference between the two. They're both important tools for having well-organized and reusable code. Okay, so what's the process for using UDFBs look like? Well, first you need to create the function block. You're going to use an instance of the function block in your logic somewhere. You're going to debug it, of course. Again, as I mentioned before, you don't want to be replicating buggy logic. You want to prove it out, and you'll do that by debugging an instance of the logic. And then once it's well proven, you can proliferate that code through that user-defined function block with additional instances in the same project, or maybe in the next project, by saving it away and recalling it later. The process of creating a UDFB is really a matter of naming it, assigning input variables, assigning any internal or private variables, assigning the output variables, and creating the logic. And as you create the logic for the UDFB, if you find that you need to add more variables, that's an iterative process which you can then perform. Okay, we're going to do a simple example today to start. This is an example of creating a user-defined function block which calculates the volume of liquid in a vertically oriented cylindrical tank. Now, there are certainly more efficient ways to do this, but that's not the point. The point is to come up with a straightforward example that illustrates how to use user-defined function blocks. So in this particular case, for the function block we're going to create, our input variables are going to be our tank diameter in linear units, so that'll be meters or feet, for instance. The fill height of the liquid, not the tank itself, but of the liquid in the tank. Again, a linear unit, meters or feet. It's a simple enough function block where we don't even have any internal variables. And our output variable is going to be the volume of liquid in cubic units. And to accomplish this, our function block needs to take into account the formula that volume equals pi times the radius of the tank squared times the height of the liquid. So let's start by taking a look at how we create this user-defined function block. Okay, I'm getting ready to show you a very simple user-defined function block where we're going to calculate the volume of liquid in the cylindrical tank. So let's get started. All right, the first thing I'm going to do is over here on my project navigator under UDFB modules. And again, this is the tag-based advanced ladder with service pack 3 for 9.9. First thing I'm going to do is I'm going to right-click under New Enhanced Logic Block. All right, and I'm going to give it a name. So let's go ahead and call it liquid volume, LIQ_VOL. Okay. All right, so with that highlighted, you now can see I have what looks very similar to a subroutine, but remember, subroutines and user-defined function blocks are not exactly the same. So let's go ahead and get started here. So as you can see, in looking under retain variables, as soon as I created the user-defined function block vol, you have this little function block symbol here, and it's added it to the list. Now, I want to add some variables to this user-defined function block. So I'm going to hit right-click. I can also use the insert key. I'm going to hit right-click and then add variable. Okay, and then in the case of a UDFB, it asks me if I want an input parameter, an output parameter, or a private variable. So let's start with an input parameter. So if I'm going to calculate the volume of water or liquid in a cylindrical tank, I need to know the diameter of the tank for one thing. So let's create a new variable. We'll just name it diameter. Okay, this is going to be a real variable. Okay, so that's the first thing we need to know. What's the diameter of this cylindrical tank? The next thing we're going to need to know is what's the height of the liquid in that tank. So let's go ahead and add another input. Okay, add variable, input parameter. We'll call that fill level. All right, again, that needs to be a real variable. So with those two things, we can calculate the volume. Now, the volume effectively is going to be the output of our UDFB. So let's add another variable as an output parameter, and we'll name it volume. Okay, and once more, this is a real variable. Now again, this is a very simple example. Okay, so now we're ready to code. Okay, so let's go ahead and put an always on contact here. Now in the case of tag-based advanced ladder, what I usually do is I'll add an always off variable, or I'm sorry, an always on variable that's tagged or mapped to %S7. But here, we've already got an array that's been created called S that's tagged to all the system bits. And so S sub 6 is equivalent to always off. Because remember, %S7 is always on, not always off, sorry. %S7 is always on, and arrays are always 0 based. So S sub 6 is equivalent to %S7. So I'm going to go ahead and add that always on contact here. Okay. Next, I'm really, because this is such a simple function, really all I need to do is a math expression block. So I'll go ahead under math operations, under expression, and I'll put that here. Okay, so let's go ahead and write our equation. Now the volume of water is going to be equivalent to the radius of the tank squared times pi times the fill level height. Okay, so that's the equation that we need here. Now we're dealing strictly with real variables. And let's go ahead and type in the equation. So in this case, I'm calculating the volume. Now I can't just type in volume here. To get the variable name proper, this volume variable is beneath liquid volume. So I'm going to go ahead and type it in like this. LIQ underscore VOL dot volume equals. Now I need the radius here. Well, I don't have the radius, but I do have the diameter. So we know if we take the diameter and divide it by 2, we'll get the radius. So I'll type in the diameter variable, and again, we have to prefix it with lic underscore vol dot diameter. We're going to divide that by 2. Okay. And then I'm going to go ahead and, well, before I take care of the square, let's go ahead and get pi in here first. So equals pi 3.14159 times my radius, and then I'm going to square that. Now I could use the exponent function. In my case, I'm just going to go ahead and multiply it by itself for the equivalent of the square function. Okay, so I'm going to type that variable in again, lic underscore vol dot diameter divided by 2. Okay, so I have the volume is pi times the radius squared, but I got to also multiply the height in here. What's my height? Well, it's the height of the liquid, or the fill level of the liquid, which in my case down here is that variable. So times LIQ VOL dot fill level. Okay, now if I haven't misspelled anything, I should be good to go here. I'll hit OK. All right, so I have just created a really, really simple UDFB called liquid volume, abbreviated there, which effectively takes the diameter and fill level of a tank and calculates the volume. So if my units are in inches, my output is going to be cubic inches. If my input is in meters, my output's going to be in cubic meters. Okay, so that's the process of creating the user-defined function block. Okay, the next step then, now that we've created our logic, is we need to test it. Well, okay, we're going to wait to test it. The next thing we're going to do is we're going to add at least one instance of this function block in our logic. Because really all we've done is created the function block, which just like the move block and the shift register, these are building blocks that you would use elsewhere in your program. So we need to effectively add an instance of that function block into our logic somewhere else, okay? And remember, each instance of the function block has a unique set of variables, unlike subroutines, which allows you to populate it throughout your code. All right, let's take a look at the next step, which is actually using an instance or multiple instances of the function block in logic. Okay, now before we start using our newly created user-defined function block, let's assume that in this application, the reason we created the UDFB is because we have a number of tanks in which we want to be able to quickly calculate the liquid volume in those tanks. So to make this maybe more of a realistic example, let's go ahead and create an array of tanks. And then to really make it useful, let's utilize the structure feature so that we can have a whole series of variables in a structured format, all tied to an array of tanks. Okay, so I'm going to start by creating a structure. All right, so let's go under retain variables, right click, and hit add structure. And again, a structure is a collection of related variables, and they can be in various types. They don't have to be in different types, but they're in various types. Okay, so I've created a new structure. Now let's name it. So right click and hit rename structure. I'm going to call it tank. Okay, real creative name there. All right, and let's start adding variables to the structure. All right, so add variable. I can also use my insert key. Let's start with diameter. All right, because we're going to want to utilize the diameter of each tank. Let's also go with fill level. Now notice these variables, even though they look like they're named the same as the ones I have up here, first of all, they're not really the same name. They're just, I guess you could call them suffixes beneath this part of the name. And also, there's absolutely no requirement for them to have the same name when you're using a structure with a UDFB. But I'm going to do it just for clarity's sake. Okay, and then let's have another one called volume. Okay, so I'm adding another variable, calling it volume. Now, some of you have probably already noticed that I haven't changed these variable types yet. I'll need to go ahead and do that. I'm going to make these all real. Okay. Okay, and then just so that I can show that, you know, I don't necessarily have to utilize all of the variables within the structure, I'm going to go ahead and create a new one called height. Okay, so this is the total height of the tank. Make that real. Okay, and when we're calculating the volume of the liquid, we don't care about the total height of the tank. We only care about the fill level of the liquid. Okay, so I've created this structure here. Now let's go ahead and create a new variable that utilizes this structure. Okay, so let's go ahead and go here under retain variables, right click, hit add variable. All right, so I'm going to create a new variable, and this one I'm going to call water tank. Okay, and for the type, all right, my type is actually going to be the structure tank. Okay, so I double click here. I go down the list in alphabetical order until I get to tank. There we go. Okay, so now I have a variable called water tank, which is following the format of the structure tank. But I have a number of water tanks. Let's say that I have a whole farm of water tanks, and let's say for the sake of argument, there's 16 of them. So I'm going to dimension water tank to 16 because that's how many tanks that I have. Okay, so now I have water tank sub 0 through water tank sub 15. Okay, and those all follow the structure with diameter, fill level, volume, and height. And there could be a number of other parameters here as well in my structure. Now let's go ahead and utilize this newly created UDFB and calculate the volume for some of these water tanks. Okay, so I'm going to go up here. So I've gone to my main area of my logic, Okay, I've put the always on contact in here, which remember is S sub 6. In this case, I had a array of system bits from 0 to 15, percent S7, which is equivalent to S sub 6, is the always on bit. Okay, and so now what I'm going to do to calculate volume is I'm going to utilize the UDFB that I've already created. So if you look here under Project Toolbox, I have a category called UDFB. So I expand that, and sure enough, there's my liquid volume UDFB that I created. So I select that here and install or locate the function block. Okay, now one of the powers of UDFB is that you can have multiple instances of the function block. So you have to name this instance. So let's call this, just for the sake of name, let's call this water tank 1. All right. All right, so I've named this instance water tank 1. Now, you'll see a pop-up of the inputs and outputs all named per my specification when I created the UDFB, and I have the ability now to fill in these variables. So let's find the diameter. Okay, I'll use the arrow key here to pull up my list of variables. Okay, so here's my water tank variable array. So I'm going to select water tank sub 0, specifically the diameter function there. Okay, for fill level, I'll do something similar. Again, I'm looking at water tank sub 0 fill level. And for my output, which is volume, I'm going to go water tank sub 0 volume. Now I happen to name these really conveniently, so it was easy to pick them off the list, but there was no requirement for them to have the same name as the inputs and the outputs. Okay, all right. So now I have created very quickly the calculation for the liquid or the water in water tank sub 0 using this UDFB. Now, if I want to do the same thing with the next water tank, I just follow the same procedure. So S sub 6, which is the always on contact, new rung here, go to my UDFB, select the UDFB. I have to give it a new instance name. This is a new instance. Okay, water tank 2, and then I go in and fill in my parameters. So under inputs, okay, this time I'm selecting water tank sub 1, diameter, fill level, water tank sub 1, fill level, and volume. Water tank sub 1 volume. Okay, so that's all there is to it in utilizing multiple instances of the UDFB that I previously created. Now, it's a very simple UDFB. It's just doing a simple calculation. It could be doing something much more complex, but I wanted to start with a simple example. Okay, so we've created the function block. We've also now applied, in our example, 2 instances of the function block. But really, before we apply it too many places, we really need to debug it. Because again, the last thing you want to do is not test your function blocks and have bugs that you're moving throughout your code. So when we debug, we really only want a single instance to be enabled. This allows us to really debug the internal of the function block with only one instance calling it, which makes troubleshooting much, much easier. So let's take a look at the debug process. All right, now let's take a look at debugging UDFBs. Now, it's very important that when you debug the UDFB itself, that you only have one instance of that function block actually running. That makes debugging effective and possible even. So what I've done here is I have temporarily changed this always on contact to a normally closed to prevent this second instance of my UDFB from executing. So now the only instance that's executing is this first function block here. Okay, so to debug, I'm now going to move over from my main module down to my UDFB module, and here's my logic. Now I could go into debug mode, but in the case of the math expression block, it doesn't show any live data. It's just the nature of that particular block. So more effective debugging will be utilizing the data-wise feature. So here I've already added my tank diameter for my first water tank, my fill level, and my UDFB is calculating the tank volume. So we'll double check the calculation here. Okay, that looks good. Let's change the fill level from 2.5 to 2. Take a look at the calculation again. Everything looks good. Okay, so we have successfully debugged our UDFB with only one instance of it actually running. So now we can, with confidence, go back to our main loop and effectively add as many instances as we need of the UDFB and be confident that it's working properly. So again, once you've debugged the internals of your function block, you can trust it just like you can trust, shift registers and move blocks and other building blocks that you can use throughout your program. And then when you use those UDFBs in your program and go into debug mode, they'll look like any other function block, and you'll see live data for the inputs and the outputs. Okay, now let's talk about some of the other capabilities in the UDFB implementation in Cscape. So first of all, you can effectively cascade UDFBs. What do I mean by cascading? Well, where you effectively have the output of one function block as the input to the next function block. But when you do this, you need to follow the rule that you can only have one function block, at least one UDFB per rung. So you don't want to draw it per the picture on the left. That won't work. But just by handling them on two separate consecutive rungs, it'll work just fine. So if you want to do cascading type UDFBs, you certainly have that capability. Okay, you can also protect your function blocks with OEM protection. Now, what do we mean by OEM protection? Well, a lot of OEMs or system integrators even, they want their users to have the ability to use Cscape for debugging purposes, maybe for making simple logic changes, that sort of thing, but they don't necessarily want to give away the secret sauce of their intellectual property. So OEM protection is a feature that's been in Cscape for some time that allows you to effectively show that there's logic in your main loop that is there, but the user can't actually see the contents of that logic. Now, that approach with UDFBs allows you to provide function blocks to your users that they can use in their program with inputs and outputs, but they can't see at all any of the secret sauce that makes up the logic of the function block itself. So the way you enable that feature is first, you have to enable security, which most OEMs already do. You also have to enable OEM ladder support. That's the subset of the feature that protects not only OEM sections in your main loop, but also OEM protected UDFBs. And then for the particular user-defined function block that you want to protect, you just right-click on it in your program and select protect, or OEM protect, I should say, and it will be protected. So again, a handy feature for those OEMs or system integrators that don't want to give away the secret sauce. Okay, exporting and importing of user-defined function blocks. This can be very useful if you want to build up a library of user-defined function blocks that you can use from project to project. So to export a UDFB that you've coded and tested, you're going to right-click on that function block in the Navigator section, select Export, and then name your file and store it away. And then later, maybe in the next project, or maybe you're going to email it to a colleague or something, later you can import it back in just by going to the Logic Modules section of the Project Navigator right-clicking and selecting import, and then retrieving that file name, which has the type of CPU, and that will bring that UDFB into your current project. Now, a couple things we don't have yet, but we're working on. We don't yet have a formal UDFB library function in Cscape, but again, using the export and import capabilities, you can certainly maintain your own library. And another thing that we're working on is the ability to add a graphics element to the user-defined function blocks. So for instance, the ability to have a group of graphics objects, maybe you've got a user-defined function block that you use for PID control, maybe that you use for pump control, and you would also like to have a group of objects, user interface type objects, push buttons, pilot lights, indicators, whatever the case may be, tanks, bar graphs, etc., that is associated with those same variables in the UDFB, so that when you create an instance of that pump control UDFB, you not only get all the logic, but you also get the graphics to go along with it. So that, again, that's not something we have yet, but it's definitely something that we're working on. Earlier, I mentioned that you could nest UDFB. So what that means is you can create a function block, which embedded within its own logic is another function block that you've created. So that's what we mean by nesting. So why don't we show an example of a nested UDFB here in Cscape. Okay, now let's take a look at another example of UDFBs. This one's a little more sophisticated, but still pretty simple. In this example, we have two UDFBs. The first one we're going to look at is a simple one called volume to gallons. So what this routine does is, first of all, it has two inputs and two outputs. One input is the volume that was calculated, cubic volume, either cubic meters or cubic feet. And what tells the block whether it's metric or imperial is this flag here, metric volume flag. So if it's a 1, the volume coming in is going to be in cubic meters. If it's a 0, the volume coming in is going to be in cubic feet. And then it's going to calculate and create two outputs, a number of gallons and a number of liters. So the logic's very simple here. If it's imperial, not metric, it's going to convert from cubic feet to gallons and then liters. If the volume coming in is metric, that means cubic meters, it's going to convert to gallons and then to liters. So that's all that UDFB does. Okay, now let's take a look at this other function block that we created called cylinder volume. So what this function block does is it takes the linear dimensions of the tank along with the fill level of the liquid, and it calculates the volume in either cubic meters or cubic feet of the liquid in the tank. Now, it would also be useful to have gallons and liters. So to do that, the way we're accomplishing that is we've actually embedded the UDFB that we just reviewed right inside this UDFB. So we're showing nested capability. In order for that to work, we have to be sure that the inputs and the outputs from or of this embedded routine are passed through. Okay, so let's take a look at the details on cylinder volume and verify that the metric flag along with the volume total is passed through, and that there's a path for gallons and liters to pass out. So taking a look here, sure enough, there's our metric flag. There's the volume that was actually calculated within this same enclosing UDFB earlier. And then here's the output path for gallons and liters. So this is another capability of UDFBs, one that you don't necessarily use that often, but it's there. And that's the ability to embed one UDFB inside another. Okay, so that's our program for today. Let's go ahead and get to any questions that may have come up. Let's see here. And meanwhile, while I'm answering questions, I think Steph's going to go ahead and put up a poll question. If you could answer that, that would be great. Okay. Oops. Sorry. Okay. Can structures, let's see here, if I can get this question. Oh, can structures be created outside of UDFBs? Absolutely. So structures, there's no requirement if you're using UDFBs to use structures, and there's no requirement if you want to use structures, you have to use UDFBs. So absolutely, they're independent features. Let's see. If you create a UDFB in Advanced Ladder, can you then use it in an IEC program? No, you can't. We don't have, we work very hard to maintain upward compatibility from generation to generation in Cscape, and as much portability as we can give you. Unfortunately, there just isn't portability between our ladder code used by our advanced ladder that's register-based, as well as our advanced ladder that's tag-based. There's no portability between that code and the IEC code, unfortunately. So that's not something we were able to accomplish. Let's see. All right, very good. So it says, the next question is in relating to how the advanced ladder with tag works. It says that I'm assuming when you create the function blocks, so the user-defined function blocks, it reserves actual registers for each value. Yes, it does in the background. It's not something typically you need to be concerned about. Are we still limited to 50,000 registers in total by doing this? So yes, you are limited to effectively 50,000 variables, or I'm sorry, 50,000 register-based variables. And how do you know when you're getting close to reach the limit? Let's see, I believe, but I'm not certain, I believe that might be information you can get from the error check function, but it might not. So I might need to follow up on that particular question in terms of specifically how do you know when you're getting close to the variable limit in the advanced ladder with tags. Can I use a UDFB created in one Cscape program on multiple different Cscape programs? Absolutely, that's the whole point. Or not the whole point, but certainly one of the points is that you can create your own library of code, maintain those user-defined function blocks, as CPU files. If you export them and save them, they're saved away as what's called a CPU file. And then as you create a new Cscape file for a new project, you can pull in as many of those previously created user-defined function blocks as you like, so that you can over time build up library of tested code that's very modular. Okay. Okay, so a question about the availability of the presentation. Certainly, this webinar video will be posted on our website. It's under the video section of our website, so that'll certainly be posted relatively soon, probably yet this week. And for those of you who are channel partners, I can probably make the presentation, or at least part of the presentation, available as well. Let's see, can you put serial comms functions inside of a UDFB? Good question. I don't know why not. Of course, if you're talking about multiple instances of serial ports, that could become an issue, right? If you're doing some sort of a open block, for instance, and that open block is pointing at a specific serial port, it may be difficult to have multiple instances of those, but I'm not aware of any specific reason why you couldn't use a serial function, but that would be one potential complication. Let's see. More specifically, can I move one structure to another? Can I move one structure to another? Okay, so a move block that moves from one structure to another. Interesting. I'll have to research that one a little bit as well. It's a good question, though. Let's see. Does the security protection for a UDFB remain with it as it is exported and then sent to someone? Yes, it does. it absolutely does remain. So UDFBs could allow building menus, could make them that much easier. Yeah, certainly. UDFBs can make a lot of things easier in a lot of cases. If it's something where you've got a lot of repetitive logic, there's a pretty good chance that using user-defined function blocks will help make that easier and more bug-free. How is the UDFB edited to modify it? Just like any other section of code. So, you know, today, from an organizational standpoint in Cscape, you can divide up, you can have multiple main loop modules, right, that you name so you can organize your main loop. You can have multiple subroutine modules where, you know, have individual subroutines that allow you to call a subroutine. And now you can also have one or more UDFBs that you can access. And in the case of all those different elements of logic, just by double-clicking on those from the navigator, you can pull up the tab that contains all the logic that you can then go in and edit. Let's see, do we have a date for the new software release? Well, it's any day now, really, with Service Pack 3. We're getting closer. We don't have too many bugs left that we're aware of. So hopefully within a few days, Service Pack 3 will make its way to the market. But I don't have a specific date, but it's getting real close. Let's see, and another question relating to software availability. So again, thanks everybody, lots of good questions. The poll results show that 14% of you have used UDFBs extensively. That's terrific. Maybe I should ask you some questions on the next webinar. 26% have some experience, so about 40% have some experience. 40% are familiar with them but have not used them, and about 20% of you were not familiar with them before today. So that's great information for us. And again, thanks for joining us. We'll get this posted on our website as quick as we can for those of you who want to go back through it. And again, we'll also get Service Pack 3 out to the market just as soon as we can as well. We're probably just a few days away from that. So everybody have a great afternoon and stay safe.